Hello, teacher. Hello, students. Welcome to today's lesson on organic chemistry. In our last lesson, we discussed the uses of ethylene and acetylene. We introduced some of the products and derivatives they form. We also talked about the role of these products in the global industry. Today, we will be introducing aromatic hydrocarbons and the simplest aromatic hydrocarbon compound called benzene. If you are ready, we will begin. Initially, aromatic hydrocarbons were so named because it was believed that they all possessed a pleasing smell. Today, the name only serves to differentiate compounds in this group. This hydrocarbon group is generally obtained from petroleum and coal tar. Aromatic hydrocarbons are characterized by the presence of a benzene ring, which is a configuration of 6 carbon atoms. They are linked in such a manner that they can form a hexagonal ring. It is called a benzene ring because this formation was initially discovered in the compound of benzene itself, which looks like this. You will notice that several double bonds seem to be present inside the ring, and that each carbon atom is connected to its own hydrogen atom. Because it possesses 6 carbon atoms and 6 hydrogen atoms, benzene is expressed as C6H6. German scientist Friedrich A. Kekulé initially suggested the structure of benzene in 1865. His suggestion was that benzene was actually a composite structure made from 2 different models. Thus, benzene was considered an intermediate form of these 2 structures. When a compound has a structure based on 2 different models, it is called a resonance structure. In resonance structures, the 2 models only vary in the position of electrons and not the position of nuclei. This means that both models will be structurally the same, but the location of double bonds is alternating, as indicated by the image here. Students, let us do an activity. The model of benzene suggests 3 double bonds. Why then is benzene classified as an aromatic hydrocarbon and not an alkene?
Students, let's get ready. Begin. let's get back to our lesson.
Hello again, everyone. This may have been a difficult question. Let us look at the answer together. Benzene is classified as an aromatic hydrocarbon because the double bonds are not in fixed positions within the structure. It is easy to think that benzene has 3 double bonds and has the same chemistry as that of alkenes. However, benzene and other aromatic hydrocarbons are not as unsaturated as alkenes because the 3 double bonds are delocalized due to resonance. Thus, they are more stable than alkenes. They also undergo significantly more substitution reactions than addition reactions, which is uncharacteristic of alkenes. This is the unique quality of all aromatic hydrocarbons. Students, let us try another activity. You will be provided with several hydrocarbon structures. Can you properly identify which hydrocarbon group each structure belongs to? You may begin.
Students, let's get ready. Begin. Let's get back to our lesson.
Welcome back, students. I trust that this was fairly straightforward. Let us go through the structures. The first structure is a cycloalkene called cyclohexene. Initially, this may look like an aromatic hydrocarbon. Remark, however, that it only possesses one double bond, even though it holds the right structural shape. The second structure is another cycloalkene called cyclopentene. Once again, cyclopentene cannot be an aromatic hydrocarbon because it lacks the right number of double bonds and only has a 5-point shape. The next structure is an aromatic hydrocarbon called toluene or methylbenzene. Notice that there are 3 double bonds in this structure. Also worth noting is the gap that exists between each. This space allows the bonds to alternate back and forth. The last structure is a slightly more complex aromatic hydrocarbon called naphthalene. This model is easily identifiable if we use the same logic that we used to identify toluene. The double bonds are all capable of alternating position without running into another double bond. Were you able to classify all the structures correctly? If so, great job. Now, students, let us complete our lesson with a review. Aromatic hydrocarbons are characterized by a benzene ring. A benzene ring is a hexagonal arrangement of carbon atoms that forms a ring structure. Aromatic hydrocarbons possess alternating double bonds that fluctuate from position to position. Aromatic hydrocarbons are generally extracted from petroleum and coal tar. The benzene ring is named after the simplest aromatic hydrocarbon, benzene, which possesses 6 carbon atoms and 6 hydrogen atoms. Friedrich A. Kekulé discovered benzene in 1865. This means that there are 2 possible structural arrangements when drawing an aromatic hydrocarbon. Therefore, we use resonance hybrid models which allow us to represent both existing models at once. A resonance hybrid defines the intermediate position between both structural models. The resonance quality of aromatic hydrocarbons makes them very stable. Because of this, substitution reactions are more likely to occur than addition reactions. It is also worth noting that compounds can be expressed in terms of possessing benzene rings instead of double bonds. For instance, toluene is a benzene ring with a methyl group attached. Naphthalene is essentially 2 benzene rings fused and share 10 carbon atoms. This concludes our lesson. Today, we have discussed the aromatic hydrocarbon group. we introduced common characteristics of this group and identified the simplest aromatic hydrocarbon, benzene. We explained the function of a resonance hybrid structure to represent the atomic makeup of an aromatic hydrocarbon correctly. I hope you have found this informative. Until next time, thank you, teacher. Thank you, students.